Next thing we're going to want to do is make it so that our character can shoot fireballs using a fireball particle effect. So you can start a sheet for all your different particles if you're going to have lots of different effects. Or if you want, you can just copy and paste a series of particle pieces into your tiles map, which is what I'm going to do because I don't have very many I want to use. This crescent shaped one here is good for fireballs. This one's good for sort of sparkly magic. And this one here is kind of good for metaball style effects. I haven't actually used this one yet. So I just got this background helper in here just to see what's behind them. Since these sorts of effects are going to be additive, that means that this could actually just stay black. And anything that's black has a red, green, and blue value of 0. So when you're adding the colors together in your additive blending, you're just adding nothing to the color, and it's going to retain the color behind it. If it's white, then it's going to add 100% of the RGB value. So then you use saturate in the shader to make sure it doesn't go over the maximum amount it's allowed. Because it's white, you can tint it any color. So you can drop your blue or your green value to make it more red, or you can drop your green value, just leaving it red and blue, making it sort of a purple. So that comes in really handy, and we can have it go through a bunch of different colors, fading from white to yellow to orange to red, and then darkening to black like smoke. So we can use that to make fire. And this is a good shape for making fire. We could also use a shape like this, which would probably be very ideal for fire, and then just do a filter on there like Gaussian blur or something, and maybe fade out the edges a little more with the eraser. This is just an example of something you could do to make your fire look a little bit better. So anyway, the reason why though I'm just using the white here and not including the black in these tiles is because I want the option to be able to use these on non-additive effects as well. So that's the reason why I'm doing that. If you do apply the black, there's a trick you can use. For example, so let's say you've been just using additive, but you actually do want this to be available for non-additive blending. You can say blending options if it's in its own layer. So you'd want to do that first, copy to its own layer. And then we'll keep this as blend of gray. We want to take the black out. So slide this up a bit and then hold down Alt while you're hovering over this one and slide it up. And now you'll have kind of a smoky edged version that works fairly good in both types of blending. So actually I have a hidden layer here, so I can make this work a little bit better with additive blending in some situations, but I'm not going to use it like that. So we're going to go into the Solution Explorer. We're going to add a new folder to take care of all our different particle effects stuff, and we're going to call it Particle Effects. Then we'll right click on that folder and add a class, and we'll start with the basic particle. And I'm just going to say platformer here. This is a small project, so I don't have to worry about that. So public vector2, and we're going to have a position and a velocity. Those are the easy ones to figure out. We'll resolve this first. And we want our particles to be able to rotate, so we'll have a rotation amount, and we want them to change size over time. And in this case, I'd like to be able to adjust the rotation velocity. In most cases, you might not want to do that. Just have a starting velocity or a general rotation velocity, and that's about it. Giving it some rotation velocity gives it a little bit more variety. So particle color, which will change over time, and the lifespan of this particular particle, the current life, like how long it's been alive, and the total lifespan for that particular particle. And you could code this too for like a starting color and a target color, and then have it so that when it reaches its target color, it's reached its lifespan, and then just have a rate that it tries to get to its goal. So there's different ways of encoding these. We're going to set it up so that when we construct a color, by default it's just going to be white. You could also have it so it passes in a starting color. Same too with the scale. I'm going to say the scale is 1 to start with. And you could use non-uniform scaling too if you wanted to do something a little crazier. Or you could even have a start scale and end scale as well. There, that's it for our particle class. Now we need something that understands how to use it. So let's add a class called Particle System. What I like to do is put in an enum up here for all my different types of particle effects. For now, we're just going to have fire, and as we add more, we'll just add more enums in here, and then different bits of code that can handle each type. And we'll put an array of particles in here, and we want our particle system to be very efficient, so that's why we don't have the particle itself doing too many calculations, in this case virtually nothing. And we're going to do as much as we can inside particle system, because when you get into a whole bunch of particles, some really complex effects, things can actually start to slow down. So we want to make sure that that's never going to happen. So this will be the texture sheet that we'll use to get the particles from. In your case, it may be your particle effects sheet or image. And I got the particles on the tiles image. image, so I'm going to take them off of that. And obviously capacity is the total amount we're allowed to have in total, and count is how many we have right now. Rectangle source rect. This is where we're getting our current particle effect texture from on text. And we'll also have a center of rotation, or center on the source rect. We'll need our particle type that we just made up there. We'll put some general parameters down here. We'll want our colors to generally start off the same. We can modify that behavior later quite easily. So I'll have a start color and an emitter world position. So position within the world, an emission velocity, so how fast it initially spits them out and what direction. And emission velocity dampen. And the way this type of dampener works is I take the velocity and I multiply it, or I say times equals the emission dampen velocity. So if this is 100 and I multiply it by 0.99, then this would become 99. If I multiplied it by 0.5, it's going to cut this velocity in half. If I multiply it by 0.1, this velocity is going to hit the brakes rather quickly. So I'll put it in a comment so that's a little easier to understand. So 0.1, slow down now. 0.999, be slow down very gradually. 1 is never slow down and 0 is stop. And we'll have an emitter width and emitter. I suppose you could do that with rectangles too. So the girth of the emitter at the location. And I'm going to call this spray direction. This is actually added to the velocity of your particle. So it's like a second velocity. Your particle has its own regular velocity. And this is the sort of general direction that you'd like your particles to go in. So that kind of channels all your particles into a particular direction. We have a float for starting scale. Rotation speed. So this is generally how fast you want them to rotate, and then they'll have their own variety, so they're not rotating in exactly the same way. There's going to be some degree of randomization of the velocity that we want to allow, so we'll set a range for that. And we're going to have a minimum lifespan and a maximum lifespan particle effects. Some of that might be stuff that you might want to hard code, just depends on your needs. We'll have a force of gravity, which we can modify as we need, and a scaling speed. And a Boolean to determine whether or not this particle system should be spawning any new particles. So is it a dead particle system? Well, technically that wouldn't determine that it's a dead particle system. There could be active particles in it still. If it's truly dead though, then it'll be dead, meaning there are no particles left at all, and it's been deactivated, and thus can be removed. So for the constructor, for a particle system vector2 location, vector2 velocity, where it is, how fast we want it, maximum number of particles. This is for how fast the emitter is moving. So you got an emitter in motion starting at this location. So if it's a fireball, it would start where its hand is, and then it would move at this velocity. And what type is it? Is it a fireball? Maybe it's some kind of sparkling healing spell. And the texture that will hold the images for the particle effect, which in our case is tiles image. In your case, it may be a particle sheet. So we're going to set our text to be text. Spawn starts off as true. We'll create our particles. Particles is a new array of particles for max particles. Let's change this to particles. Capacity, we'll set it to particles dot length. For int I equals 0. I is less than capacity, I plus plus, and we'll create each particle. Rather do it all at once right at the beginning. And we also got the location in here, so let's set that. Emitter world position is the location. And we got how fast that emitter is moving. So emitter velocity is equal to velocity. And our particle type, we'll set to the type that was passed in, which will be fire, most likely. We'll just set up some common settings, things that probably won't change between most particle effects. The emitter dampening, so by default we'll say that it never slows down, so that'll almost definitely be overwritten. The rotation speed, 0.2 on a scale of 0 to 6.28. 6.28 would be instantaneous rotation. Emitter width is 0, so it'll just be exactly at the location by default anyway. Probably change that. Minimum life, we'll say 20 probably. So now let's put in some custom settings based on the particle type. Now, if you got a whole bunch of particle types, you might want to have another way of delegating or whatever, especially if you start to give those particles, if you start to give them unique physics, then they may each need their own function that they'll have to point to. And we're not going to be doing anything quite that crazy, so we're going to say particle type fire. And we'll just have this one case in here. Fairly simple. Fire will have a spray direction. Horizontally, it's not going anywhere, but it wants to move upwards as fire would like to do. These numbers, of course, you just play around with them until you find something that looks the way you kind of want it to look. Velocity range. In fact, you can create a particle editor mode that allows you to just spawn a particle in a location and then use keys on your keyboard to input the changes that you want. So in game one of your game states might actually be particle mode test. And that way you can create different types of particles, have it show on the screen what your values are, and then use the keyboard to adjust the values. And that way you can come up with a wide range of particles for your game. You can just write those down or even have it save those numbers to file and load them in. Start scale and the scale rate. As you can tell, I've obviously played with these numbers before and I know which ones work to make a decent looking fire. Max life 51. Start color 125 for the red, 51 for the green, so it'll be like a reddish orange, a slight hint of blue, so it's kind of a slightly brighter color. Source rect equals new rectangle. So I got this source off of my tiles image, and you'll just have to figure out the coordinates, width and height of where your particle is, like if it's a star or a piece of flame off your tiles image or your sprite sheet for your particles. And then after our switch case for particle type, we'll set the center to vector 2, source rect width divided by 2, height divided by 2. And we're kind of forced to do that after because this source rect can come from a wide variety of different places depending on what particle type it is. So we can't put that up in common settings. Oh, new vector 2. There we go. And we'll most likely need something to reset all our particles. Public void reset. Just a fairly simple short method here for int p is 0, p is less than particles length p plus plus. And all we really need to do is set the life for each particle to 0, and that'll essentially reset those particles. Set the count to 0 because we don't have any on the screen right now, and spawn to true because we're setting it so we need to be able to spawn.